Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video we're going to have a chat about the recent festival I went to. This is normally held once a year in Inglewood, and I was showing Fred off along with Spot Micro, to a lesser extent, and MR4 at the same time. I have got some photos, but I didn't get any video from the event as I was on my own at the time, and so I'll show what photos I've got. Leading up to the event, I did do a fair amount of work in trying to get Fred ready. That meant building a whole new right arm assembly, and I also had to replace the left shoulder assembly, which I also replaced the bicep for. I printed those in resin, and as you may be aware from my videos on the head, I printed that in resin as well. The original head on him was printed in PLA, and I did have to remove it, so I decapitated Fred, for lack of a better word. So here's an image of Fred's with no head, and I did have Fred's head in my hands with the whole neck assembly removed. It was easier to replace from the neck up, or including the neck, because I already had the wires for the new head running down the neck, and it meant I didn't have to try and pull wires out of the old neck while I was doing it at the time. Once I had finished, I reinstalled his head, or his new head, on top, and got it all back up and running, and he looked all right. Looks a lot better once you put a face on him, as I did here. It's not well fixed, the face mask, at this stage. I will look at doing that in an upcoming video. On his backside, I had a Raspberry Pi 4 installed in his old head, and the Raspberry Pi 4 is lacking just a little bit too much, or just too much power lacking in the Raspberry Pi 4 to run the eMove system properly. So as part of building the new head, I also got a Raspberry Pi 5, and in this image I've got the Raspberry Pi 5 in my hand, and that's roughly where I plan to mount him. And hanging down off a few wires down near the bottom of the robot, you can see a 12 amp switch mode power supply. Now, the reason I have all these switch mode power supplies is eventually I want to be able to run Fred off batteries, and the batteries I've chosen to use are the 20 volt power tool batteries available from the Aldi supermarket, and they come in a variety of capacities. An example would be this 4 amp unit, and these have a nice convenient indicator for charge. And the way I've designed his back holder, what was originally a battery cover, I've added on these two holders so I can hold two batteries on this. So eventually I'll set them up with diodes so I can change them out one at a time without losing all power, and that'll allow Fred to run on batteries. In the meantime, he's still running on a switch mode power supply that's delivering 20 volts, sorry, because that's what these batteries are. So in order to break it down, I have a number of switch mode power supplies to take the 20 volt DC and convert it down to either 5 or 6 volt, depending on where it's being used. So the little 12 amp unit switch mode power supply hanging down the bottom there is just for the head. It supplies power for the servos, and only the servos. You can actually see, if we look at the top right, that's the PCA 9685 that's used to drive his shoulders and his neck servos. It also controls the torso servos. Immediately below that is a 20 amp switch mode power supply that takes the 20 volts and converts it down to 6 volts. and below that is a 5 amp switch mode power supply that supplies power to the Raspberry Pi. Moving on down further on the right side there, we've also got another 20 amp switch mode power supply that takes 20 volts and converts it to 6, and that feeds through that ribbon cable on the right hand side through the shoulder and down the arm to feed the servos in the forearm. And I have a PCA 9685 in the forearm driving those servos and the bicep one, and then past those in the hand I have an ADS 1115 16-bit 4-channel analog input module. I've actually got 2 of those in there, so I've got right ADC1 and right ADC2. I'm using all 4 channels in the first one and only one of the second unit, and that all works through the I2C bus. On the left hand side, going from top to bottom, we've got hidden behind that cable, which I did tidy up later. That's it after I've tidied it up. I have a TCA 9685 just under that ribbon going across. Underneath, that's a I2C bus multiplexer. So when you've got limited numbers of addresses on some devices, you need to split your bus up so you can have more than that limited number of addresses, and that gives you up to 8 more, or 8 times as many devices of each type. An example of limited numbers of addresses would be the MPU 6050 as an example, where you have only one address that can be set as I think it's 68 or 69, and there's no other options. So if you put more than 2 MPU 6050s in, that's it, you're snookered, unless you use a bus multiplexer, in which case I can get up to 16 of them. Not that you would ever want to have 16 of them on there. That ribbon going across with the cable ties on, that actually feeds down the left arm and goes to a PCA 9685 there. Further on down is in the hand itself are 2 more ADC, in this case the ADS 1115s again, which is supported by my Robot Lab. And I've also got an MPU 6050 in there in the hand itself, so I can tell the orientation of the hand. That is currently not being used. Below that I2C multiplexer on his back, I've now got the Raspberry Pi 5 mounted. Below that, I've got another 20 amp switch mode power supply that converts the 20 volt to 6 volts for the left arm or left hand assembly. And if you do the maths on all the servos in the hand plus the bicep, 20 amp is more than enough for that small load, or for that load section, which is the same on the right hand side. And between those 2 big 20 amp switch mode power supplies, I've got my 12 amp switch mode power supply mounted just below the back battery cover bracket, which also helps hold the back cover on. During testing, before I put his back cover on, I did manage to break, the robot started to fall over backwards, and I did manage to break that back cover. But using the 3D pen in the picture, I was able to repair the cover so that it was still usable for the day. You can see a little bit of the crack down the bottom that runs literally top to bottom, and it did break a couple of pieces out, which I was able to weld back on. So once that's installed, it does look a little bit better. It hides some of the mess, and then I've got the battery cover on the bottom down there, and at the top It's actually a 7-inch LCD display for a Raspberry Pi, and there is a Raspberry Pi 3 attached on the back side, but in this case I'm just using it as a cover to fill in that hole. There is actually a proper cover floating around somewhere, but I couldn't remember where I put it, and I think it was painted silver, the one I made up, or the one I had installed in there at one point. It was mostly young people who were interested in the robot, and I did get some photos of people with him. On the back wall, I was actually in a takeaway store where I could get power and Wi-Fi. The owner of the takeaway store thought he would be a good drawer in for his business, so it allowed me to show off the robot to a lot of people and try and encourage the hobby of robotics. And he supplied all of the power and Wi-Fi for him, so that was handy. We got him set up and running. You can see in this photo I had Spot Micro on his stand down the bottom. Some people who had heard about the robot who I worked with from day to day, this is one guy who actually got to see the robot in real life for the first time. And in this one you can see MR4 sitting down in front of him, and you can see how I had photos by CyberSyntech, or images from CyberSyntech. These are his build instruction images, and they are actually a very good representation of the robot. So I've got a picture by Gael on the left there, then the 6 images created by CyberSyntech building a standard InMove, and there is another photo on the right hand side. Some of the kids thought it was really cool. I didn't get a photo of it, but this young bloke actually showed his sister, and she got a hell of a fright when he asked the robot a question and the robot answered. She wasn't expecting the answer. Some people were interested in the way it was built using standard remote control servos, things that they've played with before but hadn't really looked at. And of course we have a young engineer in the making here. This guy really wanted to pull the robot apart to see how he worked. I did have problems. The neck and the shoulders and the torso were not working. The night before I did smell some electrical burning, and I couldn't find where it was from at the time. But after discovering on the day that the shoulders, neck and torso didn't work, I was able to track it down to a PCA 9685. Now this is an early Chinese copy of the original Adafruit design. And one of the flaws in the original design from Adafruit, which they have since fixed, was to have a power transistor, or a small MOSFET transistor, used as reverse polarity protection. The problem was in the original design it was too small, and if you had a fair bit of load on it, as I did in this case with some large servos, it has a tendency to burn it out. The throat servo for Fred is probably underpowered for the weight of the head, and that's because I used resin at 100% infill instead of using PLA or PETG or ABS with a lower infill level. So being a heavier head, I don't think it was able to lift it very well. It still has trouble lifting it, so I am going to have to change that servo out. I think it's only a 20 kilo servo, so I plan to install this 35 kilo servo. This is a 6-volt servo, and I've been using the same servos in the robot dog, the Spot Micro. In later Chinese versions, they simply omitted that transistor, and there is no reverse polarity protection for them in the later ones. And this is the same type as what I've put back in now. If you look on the Adafruit website, they have a new version where between the power connections and that capacitor, they've got the bigger, much bigger power transistor for the reverse polarity protection, and they've put the power LED on the other side. Now that power LED is for control power and not servo power. It should be noted that they are two very different power circuits. So the capacitors on the servo power to help with surges caused by servos when they first start moving rapidly, and that feeds down to the red row of terminals. Ground is common between the power terminals for the servos and the controls power, and control power runs the LED and the main chip, and therefore the outputs going to the servos. You can run these on 3.3 volts with your servos running as high as 7 volts, and it all works quite well. Just a note in this image, this particular I2C servo driver is actually set for address 41, as noted by the solder bridge on the addresses on the left hand side there. Moving forward, other things that came up. I managed to break a linkage inside the head. Actually, I broke two. I've replaced one so far. I managed to break this linkage, which I've since replaced. But a little bit harder to replace is a linkage inside here. Now, in the original build, when I was building this head and that eye mechanism, the version I used had the little nubs that go onto the eye and onto the servo, and you had to put some filament in the middle to join them, or a screw or something. I used PLA filament, and unfortunately PLA filament does become brittle over time, and that's what's happened in my case, and it snapped. In later versions of the eye mechanism, these were replaced. Instead of just having two little nubs, they are now complete pieces. So I'm going to replace those two with these two and bring it back into operation again. So moving forward, I'm going to have to pull the servo that's buried right down in here, pull it out to replace it with that 35 kg servo. I've already replaced the PCA 9685 and got the shoulders and torso working again, along with the neck sort of. So I'm going to have to pull the top skull off in order to get to the eye mechanism, and I'm literally going to have to pull the whole front of this off so I can bring the chassis, pull the front chassis off. I'll probably end up having to remove the neck so I can pull this piece out, and that'll allow me to pull the servo section out for the neck. It's a fairly substantial job, so I'll probably end up pulling the arms off at the same time. But I might do that as a different video. Another little problem I ran across was the NeoPixel light, or NeoPixel ring. So most NeoPixel rings have 16 NeoPixels in there. I've actually got some more in there, bringing the total up to 23. But one of the issues I had is I hot glued it into place, and it didn't occur to me at the time that these NeoPixels actually generate a bit of heat, and it's been enough to melt the hot glue so that it falls down inside the cover there. So at some stage I'm going to have to pop this cover off again. I did glue it into place with hot melt glue, but it should come off without too much hassle. I did do some experimentation in the early days with that. These are PLA printed, and I used a transparent filament, but with infill it becomes translucent. And I did try with 3 different levels of heat and infill. I also did some, this one here I used a Sharpie to mark the fingerprint, but these two were filament change to a black filament to do the fingerprint, the same as the one that I'm actually using. So these were the three real ones that I was playing with the most, and I actually found the one that was most translucent, not transparent, was actually the best one to use. So if you're looking to go for transparency, the LEDs actually, the light from them doesn't disperse through the transparent, and it's really hard on the eyes. You can actually see the LEDs. If you go with the translucent, like a more translucent color, it disperses the light from the LEDs. It actually looks much better, particularly when it's running something like a rainbow pattern. Well, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, and ring the notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have both Patreon and YouTube membership, and you can join my VIP patron GoLucky, my All Access patron Jerde, my Builder patrons Al Morales45, Andrew Cardone, and Gary in helping to support the channel. If you've got any questions, feel free to leave a comment below or drop into the Discord and ask there, and I'll do my best to answer your questions. I do see the questions in Discord before I see the ones on YouTube, so they'll generally get answered a bit quicker. And I'll see you in the next video.